In our last class, we talk about the K-map and we learn how we could use the K-map and get the most simplest form of any Boolean function. So we start with the function with two variables, then we learn how you could have the K-map for the function with 3, 4, and 5 variables. So for all of them, so usually the function that we had, the function form was in the form of the sigma midterm, and after we simplify the function, we usually end up with sum of the product. So if you check the old examples that we had, this is the last example that we had. So we use the K-map, and what we end up, the simplest form is in the form of the sum of the product. So you see the sum of the product, you have some product, and some of them is your simplest form. And usually the function that you had, the function was in the form of sigma midterm. So today we want to see if your function is in the form of product of the max term, how you could simplify the function, and what should it be the last simplest form that you got. So let's see how we could use that second standard form and use the K-map. So this is our topic. So we are talking about the product of sums simplification. Simplification. So as usual, we start with one example. So suppose you have this function. So function form is fxyzw. So this is our function f. The function f is the function of x, y, z, and w. And it's equal to, so unlike the previous examples that we had, so usually we got the function in the form of sigma midterm, but here we have that as a product of the sums, which is the pi max term, and the numbers that you have is 0, 1, 5, 6, 8, 6, 8, 9, 12, 13, 9, 12, 13, and 15. So this is actually the first difference that we notify if we compare these examples with the previous examples that we had. So here we don't have the function in the form of the sigma midterm. We have that as a form of the product of the max term. And we want to learn whenever your function is in the form of the product of the max term, how should it be its K-map and what we need to change in the K-map. So as usual, the first thing is you need to take a look and see how many variables do you have. The function has 4 variables, x, y, z, and w. So that means the K-map has just 16 square. So here just have a K-map with 16 section. So here we usually put X and Y, and here we put Z and W. So here we have 0, 0, 0, 1, 1, 1, 1, 0. Same thing for here. We have 0, 0, 0, 1, 1, 1, and 1, 0. So this is exactly similar thing with what we did the K-map whenever function was based off the sigma of the midterm. So no change so far. So you write for each of these square, you write the corresponding max term number. So see here, each of these square is corresponding to one max term. So what is the number of the max term? The xy is 0, 0, zw is 0, 0. So definitely should be max term 0. Okay. So similar with the others, so it should be 0, 0, 0, 1, x, y is 0, 0, zw is z, z is 0, w is 1, so definitely it should be max term 1. And you go and find that number for all of them. So this should be 3, this should be 2, should be 4, and this should be 5, should be 7, this should be 6, this should be 12, this should be 13, should be 15, should be 14, should be 8, should be 9, this should be 11, and this should be 10. Okay, so far everything is similar with what we did whenever function is in the form of the sigma midterm. But the only difference here, each of these square is corresponding to the one max term, not mid. So take a look to your function form. You have sigma max term 0. So you comes here and put 0, not 1. So remember, whenever the function was in the form of the sigma midterm, so we put actually 1 here. Whenever it's in the form of the pi max term, so in the corresponding number, that max term is 0. So remember, we learned that in the previous chapter, and we mentioned whenever you have the max term, if you draw the truth table for this function, in that specific row, which is here is 0, 0, 0, 0, the function is, the max term function is 0. So that's the reason you put actually 0 here in the corresponding max term. So continue to complete that. Max term 1, it should be 0. Max term 5, it should be 0. In max term 6, it should be 0. The max term 8, should be 0. So here we have 8. So again, the next is 9, 12. So this is 9. So this is 12. And we have 13. So this is 13. And we have 15. And this is 15. Okay. So we actually have all of them. So then we actually go and put these zeros inside the group. The 0 which is our neighbor or adjacent, you're able to put them inside the group. Similar with what we did before, the number of the groups should be minimum and their member should be maximum. So here I start with check the group with 16 members. So do we have the group with 16 members? The answer is no, because you should have the all 0 here that able to one group with 16 members. So you refuse that, go and find the group with 8. We have any groups with the 8, 0? The answer is no. We had once 1, 0 here in the 4. We could actually select these as a group with 8 members. But here you don't have 0 in 4, so that means you don't have any group with the 8 members. So then you go and check for 4 and see what we should have. So we have 4. We have actually too many groups with 4 members. So here, so 1 is the obvious, 1, 5, 10, and 9 is the one group of the 4. So we could actually change the color, have the next one. So what is the next one? So let's do the one that is obvious. So we could actually consider these as another group with 4 members. So do we have more? So let's check to change the color and see if we have one more group of 4. It looks yes we have. So if you could select this with these 2 that you have here could be covered and could be one group with 4 members. Okay. So how about the only thing left is these number 6 and 15. So we see could we make any group with 4 members? The answer is no. We need to actually go and check the groups with 2 members. So do I put these 0 here on 15 in any group with 4 members? The answer is no. So I have to consider these as a group of 2. How about these 0? I couldn't put in the group of 2. There is no neighbor for that. I have to put that in group of 0, right? So I put that just in the group with the 1 member. So this is actually 1 members. Okay. So let's start to write the corresponding term for each of these groups. So here, just be careful whenever you want to do that, because the function is in the form of the product of the max term. Again, the simplest form should be in the form of the product of the sums. Let's see how we could do that. So first I'm writing the corresponding terms for this group of 4, which is we put inside the yellow rectangle. So check their x. The x is 1 and 1. So remember, in the max term, whenever the variable is 1 and 1, it's get actually the prime. So for that reason, it should be x prime. Okay, so x prime, and the format is product of the sums. Okay, so that means I have x prime, and see what else I could have. Check the y here. So the y is 0, 1 in this yellow group, so it's gone. Take the z. Z is 0, 0. So whenever it is 0, 0 in the max term, it should be no prime. Okay, so that means you should get the z here with no prime, again plus. And what next is the w. W here is 0, here is 1. 0, 1 will be eliminated. Okay, so we don't have any w. Okay, so I just raise this, and this is what we got, or the corresponding term for the yellow group. Just again, be careful here whenever the function is the form of the pi max term or a product of the max term, the simplest form also should be in the form of a product of the sums. Okay, so write the next sentence. So here I could summarize that for the max term. So unlike the min term, here whenever you have 0 to 0, it should be no prime. 0, 1, 1 to 0, eliminate or delete. And 1, 1 will be the prime. Okay. Should be prime. Okay, so which is the difference with what we had for the midterm, right? In the midterm, 0, 0 get prime, 1, 1 no prime, 0, 1, 1 to 0 delete. But in the max term, it is exactly the opposite of that. Okay, so let's go and write the corresponding terms for this group of 4, which is they are in the color of the green. So, and see what we should have. So see, you see these green 1, 5, 13, 9. I'm writing the corresponding term for that. So again, here is a pi of the max term. The format should be the max term. And again, take a look to the xy in this group of group, which is inside this green box. So if you move here to here, so the x and y change 0 to 1, we will not have any x and y. So z here is 0, which is get no prime, plus and the w is 1, get the prime. So it gets actually, so this is a corresponding term for these group, which we put inside the green circle. So let's write another one, which is these pink that we have. So let's change the color to the pink and write the corresponding term for 0, 1, 8, and 9. So let's see what we have. So again, x here is 0, here is 1 is gone, y is 0, 0. You should get the y. Plus, and check the z and w. Z is 0, 0 should be 0, and w is 0, 1 here should be gone. So that means you should have y plus z. Just double check, make sure we did right. So 0, 1 is gone, 0, 0 get no prime. And here again, you have 0, 0, which is should be no prime, and 0, 1 should be eliminated, no w. So that's right. So so far, we actually had x prime plus z, z plus w prime, and y plus z. So we are gone with the group on 4. So let's go and check the others. Here we have with the black group of 2 members, 13 and 15. Let's change the color and let's write the corresponding term for that one. So as you could see here, we have 13 and 15. So again, check the x and y. X and y is 1 and 1. So they should get the prime in the corresponding term. So should be x prime plus y prime. And I'm writing 13 and 15. X plus prime, y prime. And then check the z and w. So z is 0, 1. So should be eliminate. And the w is 1, 1 should be get the prime. So for that reason, I'm writing w prime. Okay. So that is the another term. And finally, we have the group of 1. So let's just change the color. So then write the corresponding term for this group with the 6 member, sorry, with the 1 member, which is the max term 0. So Again, you need to check what should be the z and w. Z is 0, so should be no prime. So as I mentioned here, 0, 0 is no prime. So that means you have x. How about the y? Y is 1, get prime should be plus y prime. So then take a look to this one, which is z is 1. So that means it should be get prime. So you have z prime plus, again, check w is 0, get no prime. Okay. So the last sentence should be x plus y prime, z prime plus w. Okay. So that actually shows what's the difference whenever your function is based of the product of the max term. If that's in the base of the product of the max term, the simplest form that K-map gives you, again, it is in the form of product of the sums. Okay, so that means if you start with any standard form, the output of the K-map is that standard form, right? That means if this is based off the sigma term, whatever you got is the sum of the product. So if it's a pi of the max term, whatever you got should be the product of the sums. Okay. So we have a function. Again, this function is the function which has 4 different variables. So the function f is the function of 4 variables, x, y, z, and w. Is in the form of the pi max term and see which max term. So the max term that we have here is max term 3, max term 4, max term 7, max term 6. Yeah, that's better to write 6 first, then 7. So the next is 6, the next is 7. We have 4, 6, 7. So then we have 12, 14, 12, 14, 14. Yeah, to correct this. So we have 12, we have 13, we have 14, and we have 15. So also we have 11 here. So we forgot 11. To add that here. And after 7, we have 11 and 2. Okay. So just double check that. We have max term 3, we have 4, we have 6, 7, 6, 7, we have 11. That's right. We have 12, 13, 14, and 15. Okay. So this is a function. Is the function with the 4 variables, so it is in the form of a product of the max term, and we want to use the K-map and simplify the function in the form of a product of the sums. Okay, so as I mentioned before, so the difference between this form and the previous examples that we had in our last class, in the last class, the whole examples that we had, the all was based off the sigma midterm. So that means all function was in the sigma midterm. So today, we actually learn if function have in the form of the product of the max term. Again, is the same story. You could use the K-map to simplify that, but whatever you get will be the product of the sums, not sum of the product. Okay, so let's do this. So we have again function with 4 variables. So the K-map should has 16 sections, right? So this is the K-map with 16 section. So X, Y, Z, W, 0, 0, 0, 1, 1, 1, 1, 0. 0, 0, 0, 1, 1, 1, 1, 0. So this is exactly similar with what we did before, okay? So that's the reason I'm just writing that very fast because we already saw that. So the numbers for each mux term, just be careful. Here each square is the mux term. So the first square is xy is 0, 0, zw is 0, 0, should be the mux term number 0. The next xy is 0, 0, z is 0, w is 1, it should be the mux term 1. It should be the mux term 3. It should be mux term 2. Okay. So go to the next. This is 4. This is 5. This is 7. This is 6. This is 12. This is 13. This is 15. And this is 14. And this is 8. This is 8. This is 9. This is 11. And this is 10. Okay, so this one is 10. So similar with the previous examples, we just take a look to whatever we have inside the parentheses here. So, and in these mux term function is 0, right? So here we have mux term 3, so you put 0 here. You have mux term 4. So that I just change the color. So here on the 3 you have 0, 4 and 6. This is 4. This is 6. So what else we have? 7, 11. So this is 7. This is 7. We have 11, which is here. 12, 13. So this is 12. This is 13, 14, and 15. So 14 and 15. Okay. So as you could see here, we actually put the zeros. So definitely the next step is figure out how many groups you need to have. So similar with what we already did, the rules is same. So the number of the groups should be minimum and their members should be the maximum, and you need to cover all these 0 that you have, all of them inside one group. Okay, so let's start with check the groups with 16 members. Definitely there is no group with 16 members. If you want to have 16 members, you should have the 0 all inside this map, right? You don't have. So how about group with 8? So we don't have the group with 8. So as you could see here, if you had in 1, 0 in 1, 5, and 9, you could actually select these as a group with 8. So here you don't have. So how about 4? We have actually, we should have some groups with 4 members. So let's select first. One is most obvious, this is one group with actually 4 members. What else we could make? There is another one which is the obvious. should be this one, another group with 4 members. So which one left? This 4 and 6 left. Could we put them inside group with 4 members? The answer is yes. So see, you if you do this, if you select these 4, sorry, these 2, and consider these, okay, and they could be one group with 4 members. So that means here you actually just have 3 groups with 4 members. So the next step is just write the corresponding term for each of these groups, okay? So let's do that with, start with the first one is the group that we put inside the yellow circle. So you have this, take a look to X and Y. So if you move here along the group, they change with the 0, 1. So no X, Y for the yellow one. So how about Z and W? So here Z is 0, here is 1. So no, sorry. So if you take a look, we are writing the corresponding term for this group we put inside the yellow circle. So if you take to the Z and W, here in all of them, it is 1 and 1. So that means the simplest form here in the max term, 1 will be get the prime. So that means the corresponding term for this should be Z prime plus W prime. Okay. So this is corresponding term for these group with 4 members. Okay. So let's do write next, which is these orange one. So let's do write the corresponding term with this group, which is inside the orange circle, 12, 13, 15, and 14. So again, if you move along the groups, so the ZW change to the 0, 1, you don't have any ZW in this term. So how about the ZW? So here is, yeah, if we actually couldn't see that, so here is 1, 1, right? So that means the X and Y here, if you move around these whole groups or members, so you have 1 and 1. So 1 and 1 will get the prime. So that means you should have X prime plus Y prime. Okay? X prime plus Y prime for these group that you see. And finally, we have these group in 4 and 12, 6 and 14 inside the green circles. So let's write the corresponding term for that group. So again, if you take a look to the XY, let I rewrite this. It's not obvious here. This is 0, 1. Okay. So just move along the X and Y. So here is X is 0, here is 1, so it should be gone. Y here is 1 and 1, so you will have Y prime plus. Take a look to the ZW. Z here is 0, here is 1, should be gone. W is 0, 0 should be double, right? So that means the last term that you have should be the Y prime and also plus W, okay? So as you could see, whenever the function is in the form of a product of the max term, so you could use K-map, and what you end up will be in the form of a product of the sums, okay? So whenever the function is in the form of the sigma midterm, whatever you got will be the simplest form that you will get from the K-map will be in the form of a sum of a product, okay? So this is what you need to be careful whenever you actually have the function and that function is in the form of the product of mux. So what it tells to us, no matter you have the function in any standard form, so that means sigma midterm or pi the max term, you could use the K-map. The only difference is whenever it is in the form of the sigma midterm, you actually, the simplest form will be in the form of sum of the product. Whenever the function is in the form of the product of the max term, the simplest form should be in the form of a product of sums.